All right, let's get started. To my Twitch viewers, thanks for joining us this Friday evening. I really appreciate it. Sorry for not being able to stream Wednesday, but work was hectic, and by the time I got home, I was just too exhausted to stream, so I decided not to. Uh, so I appreciate you sticking with us. To our YouTube viewers, we really appreciate you continuing along with this video series and checking them out as we drop them. I know sometimes uploading gets a little hectic. I try to upload on the same days that I do a stream. I noticed not one-to-one. I got a little bit of a backlog of videos just in case I don't stream, or anything happens. That way I have videos I can upload and keep the channel, at least with some somewhat refreshed content. So where we left off, we had kind of pretty much gotten the non-volatile storage system subsystem working, basically just to store the cycle count. So let me go to VS Code and our wonderful PuTTY interface. I just got things up and running. Pardon me. Long day. Got things going, making sure, brought the board up. So one of the things I want to start touching up on is the system status. This is where we're going to store all of the basically we'll store a flag, like a byte, basically 8 bits of data, and just use them as like an error flag sort of setup. That way we can basically just have a way to toggle the status LED to turn it on, to let us know that something is at fault, and then use these status bits basically to store at least what is at fault, or what general part of the system is causing a fault, like the limit switches. Is a non-volatile storage system operating properly? Is it faulting out? Is the temperature sensor, is it overheating? Do we have a general fault from the stepper interface? So that kind of stuff. So those are the kind of faults we want to be able to at least have access to. So if there is a problem with the board, we can at least see a good general problem with it. At least a general idea where to look to troubleshoot it. So in here, system status, we don't need the UART driver. Okay, I don't know if we're going to use any of the log, but we'll leave that in there for now. It isn't going to hurt anything. So the status LED pin. Again, these are supposed to be droppable modules. So we have the status LED pin. Let's see if in our main we are calling the system status.h, the header file. So we are, let's see here. Can we leave the task in there? No. No, we don't need that anymore. We don't need that. Let's see here. Let's go ahead. Okay, so we have our status LED pin, which will get carried over. So we do need GPIO. So we are resetting it. So it's output 0. Okay, perfect. So we've got our status init. So let's kind of figure out our structure here. So I'm going to bring up a notepad real quick to use as a little scratch pad for this. I clicked on the wrong thing. Okay. So we're going to go with basically 1 byte, 8 bits. So we're going to start with, so So we'll have, you know, bit position 7, 6, 5, 4, 3, 2, 1, 0. Descending order, because that's typically how a byte would work. You know, most significant bit would be first. So let's see what we want for, you know, bit position 0. Let's just say limit switch errors. This way we'll have like kind of a point of reference. So at 1, let's see. So we have a limit switch, which could fault out. We had the NVS system. Let's see here. Let's open up the NVS system and see what could error out. Okay, so storage open. All right, so bit position 2. NVS system. Reading the cycle data. Reading the data. All right. Now, general, because again, there's a fault pin, but it could indicate any fault. Could be like a overcurrent fault, could be a over temperature fault. Any of the, it's just a generic fault output on the DRV8825 chip. So it could literally mean anything. So it's just kind of like a generic fault, but at least point us in the direction. So if the system's not working right, we can say, hey, we got to look at that around that chip to see, you know, what could be causing the problem. See if it's overheating, but hopefully we could get that, because we could get maybe a better since we have the temp sensor, we can also monitor for over temp. So we can kind of set a threshold temperature to monitor for. And basically, you know, if we hit that threshold, if it gets too hot, obviously the temperature sensor interface, the driver we write for, will operate the fan, but also fault out if it starts reading a temperature over fault or over temperature condition of the board. We might want to then factor in other things that we could do with this. So one of the things we could do is we can use the system status to maybe also control the actual stepper motor. So we could set it up so here we could set control status. So if we could set this up to where not only the control 1 status, basically that button, but also if this byte, the entire byte for the system status is 0, basically there's no faults, then the system will run. If there's any faults, the system shuts down. So I think that's what we'll do. So system.c, that's the NVS system. We don't need that. System status. So this only needs the so variables. So we're gonna just do we're going to initialize it at 0, basically at each reboot of the system. It's going to be just self-contained. So Oh, actually, no. It's going to need to be external because we need to be able to pull it into the RS-45 to read that status byte. All right. So let's grab this guy. All right, let's grab this guy. All right. So we have the status byte. That gets set to 0 at program bootstrap. Now we need to figure out how we want to shove the data in here. So we've got all these different systems. So RS-45. So the system so far, the DRV8825, but we can monitor that fault pin from the system status, but it might be better to kind of monitor it in the DRV8825 subsystem. Decisions. I think because we would see. I'm thinking we could use a because I need to be able to get access to this system byte through multiple different sub interfaces. It just means we'd have to flesh it out and then include its header into all the other systems that we want access to that system, that status byte. I'm going to have to figure that out. Because there's got to be a better way of doing that. Maybe using a pointer? Let's just kind of Google this stuff here. Actually, let's ask Copilot to help me out here. Okay. Right. Let's see, maybe all right. All right, let's see here. All right. Actually, it's pretty pretty much okay, so Copilot pretty much told me to do it basically the way I was already planning. I just have to incorporate the system status header file into the sections that actually would need access to it. Great. Okay. All right. Well, I guess we're just gonna do it that way. All right, so we have status byte here. So we also have this. So we've got 3 more bits that we can use for things. Now, since the fan not... So we could, when we go to rate the temperature interface, we could set it up to monitor the tack on the fan. And if it's supposed to be running and the RPM is not above 0, or let's say above a slow arbitrary value, that could indicate the fan is not operating, it's stuck, or it's just failed, or another subsystem failure, or the fan not present. We can throw up a fault for it. So we can throw that into here. But that can be handled in the temperature driver, not the temperature sensor, that monitoring system. Because I'm half tempted to use the system status as kind of like a central hub for all that. It may actually be in here instead. So what we could do is we could pull the fan into here. I'm not pulling the fan in here, I don't think. We don't really, we only need it because we're declaring the pins. So let's go into system status. Oh, we'll just copy this guy. So we need the PWM fan mainly so we can issue commands and monitor it. Yeah, I think that's what we're gonna have to do. I think this is a status. This is gonna have to be basically the delegator. It might actually kind of clean things up a little bit. All right, so in main we have system status.h. Let's put that mainly because I don't know how it works. Okay, that way it pulls that. All right. If control and status byte. Equal. What we could do, so no fault would be a status of 0. Let's see here, system status C. So it wakes up, status byte equals 0. See if it builds and doesn't complain about anything. And then I want to test it real quick. Oh, I want to make sure my logic, before I get too deep into writing this stuff, and my logic. All right. Make sure we can flash. I want to make sure it runs because the status byte should be 0. So the system should run. Okay. Okay. So it is reading the status byte as 0. Perfect. Great. All right. So my logic, mentally, my logic is working. So good, good, good. So that way, if there's any fault, any system status failure, then it won't work. You know what? Let's test it. Let's actually give it a fault. We may put blink codes in, but I don't know. I don't know if it would be beneficial. We'll see. Right now, the whole idea is just to at least capture the faults and turn the status LED high. So. Okay. It's not operating. Perfect, 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 perfect. It is doing exactly what I want it to do. All right, make sure we set that back to 0. All right. Perfect, perfect, perfect. Okay. Now, do we want to create a task? I mean, it's not really necessary. But, you know, let's go ahead and create a task. All right, so C. I don't think it needs to be a static void. We don't need any. Okay, so actually we do want it. Monitor task. Okay. Okay. So we do want a status monitor task. So let's get this stuff. All right, let's copy this. So after it inits, all right. Status task, or let's call it monitor task. Because it's got to be 13 characters or less. 12. All right. Okay, okay, okay. All right, we're fine there. And status monitor task. So in here, in this task is where it's going to, so I do want to copy this, go in here. I always forget all the formatting and all the things. So for me, it's just easier to grab here, the task delay. Want to make sure we put that in here, because if we don't, did it not? There we go. All right. That way we don't lock up the system Okay, so we've got the task delay in there. Okay. So we have the status byte. So I guess the first thing we want to do, if well, it's a task, so it needs to be a loop. So oh, status byte does not equal 0. We are going to level set it back to 0. All right, so I'm going to do 2 test uploads of this just to make sure. Oh, derp. Okay, I'm a big old dummy. Okay. So one of the things I've learned, never be afraid to build often and test your code before you get too far ahead of yourself. The last thing you need is to be working on something. And so the LED should be off. Flashed in there. Enable. Okay. LED is off. We're going to set the byte to 1. Build it. Now, I probably could have thrown some quick debug code in the RS-45 to toggle that status byte to change its value, just to have the system act up, just to do stuff. Let me see here. Okay, it moves. All right, let's flash her. Reset. Oh, yeah. Okay, and now it won't move because the status error. We go. All right. 0. Not going to build it yet. Do I have, I mean, I could just go and throw it in there. Do I have system status? Go ahead and add that. Oh, I hate when you do this. Don't do this to me. Dot. All right, so there we go. Not really status command. That is, yeah. All right. Set status number. All right. Get status. The set status will probably this will get the current all right, so all right, let's see. Get status. Current system status is, it's just not a long status byte. That should work because it's coming from the status system, so that'll get that. And then, so we need to rip this apart. Set status. And status value. All right, so then we're going to, all right, here. Get rid of this because we're not really going to care. It's just, status set to percent %u status val. Right. And then there we go. All right. So make sure that we are, make sure 0. Let's see if it pukes guts out. So far, no. Okay. Okay, flash it. Okay, reset, enable. Okay. So 0, which is proper. We have no errors. All right. Why is it okay? Wait a minute. Okay, so it's resetting back to normal for some reason. Why is it? I mean, it sets it really a flash. Hmm. Why did it reset? So it does set it for a moment. So nothing here should be. If it does not equal 0, is it being reset anywhere else? No. Okay, that's just really weird. Anywhere else this is setting the status. No, that is so weird. Why is the status getting... There's nothing else I should be setting it to 0. Monitor task. Status plate. Not using it right? Maybe I need to... Maybe I'm doing something wrong. Why does my keyboard hate me? Come on, keyboard. All right. Join. Let's see what she does. What are you? Oh God, you failed it somewhere. Define. Wait, what? next turn. Just include the header. What? Okay. Oh, don't need this garbage here. Oh, you know what? I wonder. C++. Let's try something. Let's put that. Okay, I think my keyboard officially hates me. What? Put that up here. Let's see if that. No. So I have it there. Substatus, not H. Let's see here. Yeah, that'll fix it because it's not fully defined up there. Let's see what we get. Ugh. Painful process here. Okay, let's reset. Okay. Yeah. Why is it being reset back to 0? No, this actually makes sense. Well, we're hitting the status. Status init. All right. Okay. Okay, that is just so weird. That sets it for like a second. Okay, this is really bizarre. It sets it for a second. And I don't. All right. See if I get a different answer here. Maybe. Hmm. Okay. Okay, we're going to initialize it here. Okay. Okay. Well, based on what I'm saying, I'm initializing it right. It's set up as an extern. Status byte. Okay, so I've got it properly configured in the header file. All right. Then in the C file that goes with it, we're initializing it to 0. It's just so weird because in the PWM fan, PWM value, XO. So it just works. And it doesn't get overwritten. Why are you getting overwritten? Well, somehow... let's try this. Let's see here. Because if we can't set the status here in an external one of the externals tries and it fails, then I might have to actually just try it with the limit switches. Okay. That's so weird. Let's try here. Do I have it? Yeah. System status. So okay. Equals. Yeah, it's gonna be 1 because that's gonna be position 1. No. All right. Since we're just testing this, we're not going to do anything. All right. Let's see what that does. So that'll constantly be setting that status byte to. So let's. Okay. Okay, so we drop the limit switches. It throws up an error. The status byte, the status LED comes on. All right. All right. Okay, so let's see if we can. Huh? I can clear it back to 0, but I can't set it to 1. But yet, yoinking the limit switches. Okay, well, we will just move on, and maybe it'll make sense later because there's nothing that should be resetting it. If status byte, and nothing's resetting it here. It doesn't equal 0. We initialize it here. over here it changes it. See, the RS-45 should set the status. Status go. You know what? I'm gonna. No. Where is it changing it? Mm. I don't know. Don't know. All right. Whatever that's going to do. So we need to fix this logic right here. So what we need to do is get this byte. Um, oh, dang it, I kind of forgot how to do something. I know I need to keep forgetting the masking. All right. All right. Status byte equals. Hello, keyboard. Wow. I think it's 0x. Yeah. 0. I think that's how the masking works. I might be completely confused, but that's fine. All right, let's flash the board because we want to use bit masking just to change specific bits of the actual status byte. Okay. Now let's see here. I think that works. So it should just be 1. All right. So I see. Okay. Okay, so we have that working. All right, so we'll say that storage open. All right. Let's go to system status. So it's going to be the NVS system. So we need to add system status to that. System C. That way we can access that byte. So if we have an error flag handler, so that would be storage open error 1 and 0x. So let's pull up the calc. I like using this guy. I like using the calculator because we have programmer. So we're binary, so it's at bit position 1. So it'd be 0x2. All right. So that's if it can't open. Basically, you can't open it. So open, we're gonna have to put that there. So now we need to make sure that it gets cleared, that it is cleared if it does open. So open, I mean, it only set the flag if it has a failure opening it. Which error? Okay, status byte. So it'll flag this error the very first time the system boots up, but that's only for a new install. When I'm going to be building and selling these, I'll flash them and do the in-house testing, so this error won't exist on devices. So that's going to be at bit position 2. So hex 4. Locate the correct key. Maybe. All right. All right. Now the copy, get that guy. And the driver, the 8825. All right. So the fault. Okay, here's the task. Okay, step fault. So the task, we're going to give it a delay as well. A slight delay, like maybe 25 milliseconds again, so it doesn't sit there and hog up everything. So then what we want it to do is if, all right. Fault detected equals GPIO get level and it is STP fault. Fault. Oh. Okay, so n will be high. We'll actually go low if a fault is detective. If fault does not equal 1, right? We're going to go here, status byte. Right? General. Oh. Yeah. I think it's about time to get a new keyboard. DRV 8825 fault. There we go. Detection only. So the status byte for that'd be bit position 3, which would be 1 B0 0x8. All right. Yeah. Because it's going to be doing this, we definitely want a little delay in here, 25 milliseconds. Again, we don't want to run into the same situation where these tasks are just stealing from the main CPU tasks and doing what it did before. I don't know if it would fault on a disconnected motor. It might. So let's see if we can get a fault to show up. Disconnecting the motor. Let's reset. Okay. We're running, no fault. I'm gonna disconnect the motor. I can't remember if it'll actually detect no motor. No. And to be totally honest, I don't know if I can actually force a fault condition on that. I gotta say though, this TPU belt is still holding up pretty good. It's still working really well. Okay, well, so we've got that. We have a so if just the stepper motor driver faults, the value returned, the decimal value would be 8, and the hex value would be 0x8. And then basically, if multiple systems are faulting out, it would be a combination of all of these. So hopefully, so we know we can force a limit switch error. Let's see here. I mean, we could probably do some soft errors with like the NVS system by like lying to it and giving it a false name. So if we go here, so where we're supposed to open, so let's go to storage. So it can't, let's say we've got that spelled wrong. Store up. Okay. I'm just trying to force some faults in here. I just want to see it get a different value other than just for the limit switches. If we can force it to get a different value other than the limit switches, that'd be perfect. Come here. Flash it, and then it should, when I reset, it should immediately fault because storage is spelled wrong. No. It does not care. What the what? What the what? Oh, you know what? It probably doesn't care what that is. You know what? Maybe if we just do this, maybe no, that'll get a compile error. You know what? Let's see if that causes a failure. Please, I actually want you to fail. Give me an error. Show me that I can get a different byte value. That's all I care about. The status byte, because if might have to try the fan, so hopefully that causes it to fail and you know we actually get an error. No. I might have to. Okay. You know what? That should force a fault. Because if it's not forcing a fault, then I don't know what in the world's going on. Or it's forcing the fault and somehow it's getting reset. And I got to figure that. We got to figure that problem out next. I'll see what this does. If it doesn't work, regardless of what happens, we'll end the video. And I'll pick up back up tomorrow afternoon. Oh. Oh. All right. Yeah, I think it's setting it. But it's automatically being reset back to 0. So I got to figure out why. We got to figure out why it's being reset back to 0. Yeah. Let's try one more thing. All right. Does that complain? Yeah, so so it's being initialized. We go status init. Main call status init. Says all this fancy stuff. And I don't know why it's getting set back to 0. Why are you getting set back to 0? That is utterly confusing. That shouldn't matter. It says RS-45 stuff is really messing with it. I don't know. It'll set it back to 0. It'll set it back to 0 successfully, but it won't let it stay. Weird. Okay. All right. Well, I'm going to end the video here and we'll have to figure out where in this circular logic, where somehow that status byte is not responding to these changes. This could be messing with it in the RS-45. What I might do is kind of pull this out, change a few other things, see what happens. We'll see what happens. So I thank you for hanging out with me tonight. I really appreciate it. And you have a good evening, and we'll catch you tomorrow afternoon.